Welcome to the Sarah Drake's Lounge. The couple of announcements. One is that we have the Western Conference in Dallas, and it will be on the 8th and 9th. That will be on the University of Texas Dallas campus, and they will be getting off and going to I don't know the exact location, but they're going to be going to see the full eclipse, which passes over Dallas. We do have our eclipse expert, Robert Lucas. He's actually wants to show off his new telescope, and we'll get him next. One other announcement is good news is I've just got my fourth grandchild. Bad news is that it's on the other side of the state, and I'm going to be traveling a lot. So I am going to announce today that I am not going to run for president this next term. So we will have the president and the vice president slots will be open. I'd recommend anybody, especially with some business experience, to think about running for those two positions. The president's job is an overall. There's not a lot of you just sort of coordinating and hooking people together, but you're overall responsible. The vice president's primary job is to run the Eastern Conference, which is a significant amount, but it's a very important job. Anyway, anybody interested in that, talk to me. We're going to put out the call for nominations. If you know anybody that would like to do that, ask them first and then nominate them. Make sure that they're willing to do it. We'll see how this goes. I'll still be around. I'm still going to be running the journal and YouTube videos until somebody else wants to take on either of those two. I'm not going anywhere. I'm just sort of letting the next wave of people take over the business side. Okay. Any comments or anything up front here? And I'm going to let Robert wants to show off his new telescope. Okay, Robert, go ahead.
Okay, so what I'll do is, what I've done is I've acquired a ZWO seestar, which is a 50 millimeter 2-inch aperture, and basically what it is an automatic. You just turn it on and push the buttons, and it does its thing. So what I'll do is I've taken some images, and I'll see if I can bring them up. Oh, there's the first one. So what the thing about this?
No problem. This happens. Ted, what do you got going on?
I've been busy with that observatory in the background, hosting groups. And so I haven't played much with ezRA or even antennas. I have some pictures of antennas deep in snow. The snow came and sat on my antennas and broke my ham radio antennas. So I'm recovering in a couple of ways.
Hey, Robert, you got it.
Oh, okay. Rob, take over. We see a picture of the sun.
My goodness, this thing has so many things on the phone. So what is everybody seeing? I see
we see an orange sun.
Anyway, that was the okay. If you see an orange sun, that's good. Okay, so anyway, this seestar, what I did was yesterday I went and I set it up on the on the lounge table and pushed the button, and this is a picture. I'm trying to get to the other pictures. Anyway, I took a picture of the sun just to see what it would look like, and it's basically easy to do, and there are adjustments that you can make to the exposure times. Okay. I can shift this one over. Let's see if I can get the next one up. Now, what I did, can you see this one?
You see a gray stripe vertical right in the center of the screen. Something's very small.
Okay, can you see the moon at all?
We just see a gray stripe. I see no moon.
about that one?
We're back to the sun, image 1 minus 3. So yeah.
So you don't see the moon. Anyway, the reason for taking a picture of the moon is the bright moon is very, the brightness of it is about the same as the corona during the total eclipse. Okay, so I don't understand why you're not seeing them. Yeah. Sorry about this.
It may be in a different window. In Windows, you have to unshare and share again to pull up a different window. Maybe.
This thing says you are screen sharing, and so you should be able to see.
Well, we see the sun.
But you don't see the moon and over it. I see the sun there. I click on this and I see the moon.
And the top of ours goes a little gray when you do that, as if we're not looking at it.
Wow.
So if you unshare and pull up a new picture.
I see a moon.
So do you see just the part of the moon?
We got a great big glare up on the top left, and otherwise it's kind of bright on the right.
You don't see
this is image 1 minus 2.
Right, but you see a detailed picture of the moon.
Yes.
Anyway, that shows you, basically shows you the quality of the images that this 2-inch telescope can do. Wow, let's do this again. Hello.
That's a pretty cool image for the tiny telescope. Yeah. I put a link in the chat so you can see how big the physical thing is.
It says I spent 19 minutes, and basically what this thing did was it goes through and it takes 10-second images and it stacks them together. Okay, and anyway, the important thing about this is being able to change the integration time, and this gives you an example of the quality of what this thing can do. And basically, for the eclipse, we should be able to stream what the device sees, for everybody, if you can't make it to Dallas for the eclipse, and that's assuming that the clouds are clear.
It says other things at the bottom of the picture. I see M44. Now, would you have typed that in, or
no, that's
looking at it?
No, the instrument does that for you. Basically what it does is it looks up at the sky, does what they call a plate solve. Looks at the stars and everything to see where it's at. And, basically it comes up with what's the best things to look at night, tonight or whatever time of the day. And you choose one of them. And this actually adds this information at the bottom for you so that you know what you've taken an image of.
And at the very bottom, I see Belmont and the time and date. What's the Belmont?
That's where I'm at. I'm in Belmont, California.
So you defined a location. Oh, that's pretty slick.
Yeah, gives you the time, which is, well, you keep asking me for the time on my radio telescope, and this one does it for you. Okay. So anyway, looking forward to see everybody at Dallas for the first time. This is just what this thing can do. Any other questions?
So as they sell them, are they having trouble fulfilling orders?
Well, when they first started, last year, they apparently sold out, and had to make a special run. And I just happened to contact one of my friends, and they said they had one, so I went the next day and saw them, and I bought this thing. And I tried to buy a second one, but that didn't happen because I think, like you say, so many people are seeing what this thing can do, and they're just running out and buying it. It's not expensive. I have larger telescopes with the same type of capability as this, with the plate solving and all of that. But each one of them is a separate item. You bought the telescope. They're like $3,000 or $4,000. Okay, even though it's bigger and does a better job, but this thing is all in one, and it fit in the suitcase and went on the airplane. Yeah, the only thing I did was I took the battery out. I thought it was lithium ion, and I thought it was too big to leave in the hold, in the checked baggage. Okay, but there's a lot more to do. Yeah.
So your technique was to carry the battery with you up in the cabin, right?
That's correct. I have one of
Okay.
these, protective, you put your batteries in it, and it's supposed to be an explosion proof.
Well, that's
One time,
impressive as
one
itself,
time,
but okay. I'm learning your techniques. Thanks.
one time I looked at my iWatch, and I said, "Oh, what the heck's the matter with it?" And basically, what happened was the battery in it, puffed up, and it just took the top off the watch. So I had to go buy a new watch. And 6 months before that, I tried to change the battery in my iPhone, and I shorted the thing out. And I go, that was frightening, even for the small size of a battery in an iPhone. Yeah, not good. So I think, so I thought, taking them out and putting them in one of these, little bags, seemed to give me some confidence. I put the spectrograph and the tracking mount and everything in a Pelican case, and I checked that, and that made it through. The Pelican cases are usually pretty good. So I have, it's not like one time when we went to Russia for a total eclipse, and what we did was we had about 25 people, and we divided all of the instrumentation into 25 separate Pelican cases, and each person that went with us in the expedition, was assigned a Pelican case, and we all, and at that time I had premier status with United, and we rocked up, and I showed them my card and the 25 people behind me, and we all got on the plane with our bags and checked all the Pelican cases. For the China eclipse, what we did was we took one of those big pallets and we packed everything on it. And that took months for the stuff to get to China, and it took months to get the stuff back from China. And for international trips, what we did was a carnet, because when we got to Russia, with all of our equipment, if we hadn't used a carnet to tell them that this is what we were bringing in and taking out, they would have charged us tax on it. And some of the filters that we use were like 50,000 US, and taxes on that becomes quite prohibitive. So instead of just walking in with them, we do the carnet routine. We had the new Nikon 1D cameras, and when we went to one of the museums in in the Red Square, they wouldn't let him in with that camera. We had to give it to one of our hosts to hold it while we went in and looked around the museum. Lots of cool fun stories to tell. Okay, any other questions?
All right.
And more later.
All right. Thanks, Robert.
I do have one question. Apparently you can get a variable size. In other words, the moon and sun should be about the same size. But I was told that I just got one of these and I'm playing with it, but I was told you couldn't see the corona and such while the sun was in eclipse, that the sun would take up the whole field, so to speak. But your first picture shows that you can see a lot of corona, apparently. Is that so?
Well, keep in mind that what you do during totality, you take the solar filter off.
Oh, yeah. Yeah, no, that's sure.
But who said you couldn't see the corona?
I don't know. It passed by me in one of these talks or somewhere else. I'm not sure where.
Well, the reason why I took pictures of the moon is because that's the intensity of the corona during the totality.
Yeah, I understand that part.
So
but
my guess is that because I can see the moon like that, we should be able to see the sun and its corona, the corona around the sun's disk during totality.
Oh, no, I didn't mean intensity. I meant the size of the field. The first picture you showed the sun in a sufficient size for the field so that you should be able to see the corona and prominences quite nicely.
Yeah, but because it's anyway, the corona, if you do a long integration, like 10 seconds, the corona is only going to be like 1.5 to 2 disks out, from the sun's surface. So So it depends. Well, I don't know how big the corona is going to be this time around. I'll have a look and I can check that out for you and get back to you on that one. But
Well,
I think, but I think you'll be able to see most of the corona, around the sun's disk.
yeah, that's what I figured from your first photo. I've seen a few.
Now that was the ×1. The pictures of the moon were the ×2 and the ×4, where and I think that's a digital zoom.
Got it.
So I'm hoping it won't be an issue during this. I'll have I'll check and see what they expect the corona to be. There's a lot of simulations, that people run.
Okay. Any other questions for Robert? And he will be showing this off during the 8th to the 9th. So if you haven't signed up for even the online for the Western Conference, go out to the Sarah store and sign up so you can watch this real time.
The one question I would have with it is, can you convince it to not use the solar filter during the eclipse?
The solar filter is something that you physically put in front of the object.
Okay.
And then you take it off at the diamond ring.
Okay.
Same thing that you'll do with your other cameras. You put the filter on during the partial phases, and then you take it off during totality, and then you put it back on.
Okay, thank you. Didn't know if that was integrated in, at which point, it might decide, no, I'm going to save myself, put it in the way.
Been there, done that. Let's hope this one doesn't do that, because it won't be in front of the optics.
Okay.
Thank you for asking. Thank you for your patience, by the way.
Thanks, Robert. Alex.
Hi, guys. Can we get back to the regular screen? I will be very quick because there's a lot of people that sometimes don't get a chance to chat. Let's see. 4 slides, really fast. I've been working with the continuing with the disc Yagi, and I've got the 25 director 1.5 meter long system working pretty well. Well, I went back and completely redid the structure, so it's pretty strong. It's surprisingly pretty much straight. Very little droop now in the 1.5 meter boom, and this is kind of signal level. I've gotten over 2 dB differential between the declination 40 RA 2030 and cold sky, and I did another analysis. This is very good. Dr. Vidmar's model, basic model, I've changed it. It very well duplicates what I have measured during the physical field tests of beam widths, and so the 0.75, which is easy to construct, it's only 30 inches long, has a fairly wide beam width. The one that I showed you before, the 1.5 meter, has a pretty good beam width, and going out to the one where I began with this French design, which requires some support wires or string, this gets ungainly. This is it's hard to keep this aligned, and the difference between the 1.5 and 2 meter long system is not sufficient to try to make it any longer than it is. So I'm pleased that this is working now. Any questions? Am I still online?
You did. It looks great.
Okay, that's it.
Okay. What do you What software are you using to come up with those plots?
That's 4NEC2.
Okay. And you just enter the physical data you got from your backyard system?
No. This is model data. The 4NEC2 is numeric electromagnetic code analysis.
Oh, okay.
This is a model. I mean, that's an NEC model, structural model, and that does the finite element current analysis for antennas.
Oh, okay.
Yeah. If you ever get to the end of this audience here, I'll bring it up online and show you what it looks like. But I'm just gonna pass the baton let some other people talk.
Okay. Nathan.
Hey guys. Work's been super busy, so I haven't been able to do the things I want to do. But I have been still working on the hydrogen, but I've been working on some mechanical components as well when I get the chance. Can you see my little PowerPoint?
Yep.
Up there? Okay. So one thing I've been hoping to do sometime this year is to add tracking capabilities to my small little telescopes and do it without, spending $300-400 per. So I've been doing some work looking at 3D printed options and things of this nature, and I've come across something that seems to work kind of well. So these are just this is just the first steps of it here. So just some of the goals, just make it kind of cost effective, something that can handle up to about 1 meter on the telescope size, something that's basically off shelf with a little bit of homebrew, and then hoping to add some rotary encoders so it knows exactly where it's at. And I'm gonna post this PowerPoint in the on the listserv later, a link to it anyways, because it is quite large with some videos in it. This way, if anybody else wants the links, they can get the links that are showing up here in blue. But I found on some websites, the first one was a parametric slew drive. So the parametric, when you're 3D printing, it's basically you can go in and you can change the parameters and it will redraw as well as it can. It'll redraw the model for you based off of whatever parameters. So you say, I want 102 teeth or I want 150 teeth. It'll calculate everything else, size, distance, and everything for you. So found that, and then I found a remix of that by this guy who's got a YouTube channel called Some Old Guy Coding. Sounds like something I would do. So I used his because it's easier to print, and it's a really neat little setup. It's a slew drive, and so it's 3D printed PLA housing with a bearing, a worm gear bearing, and the worm gear drive on one end that's powered by a NEMA 17 stepper motor. And the bearing balls inside of this bearing are actually the 6mm plastic airsoft BBs, the ones these kids go out on the weekend and pop each other with. But you line the top and the bottom all the way around with these BBs, and that provides the surface that it can rotate around, put some lubrication in there, and it actually works really well. And so all I'm using, like I said, is just this 12-volt 2-amp DC NEMA 17 stepper motor, and it's basically what you would find inside a desktop CNC or 3D printer. They're little guys, but they have decent torque at about 59 Newton centimeters, which I think is about 80-ish ounce inches, something like that. And then also I have a little stepper controller hat on an old Pi 3B Plus that I've had sitting around here for a while. So just running some Python code through this, which then drives the stepper motor, which then turns the worm gear, which then turns the slew bearing. part of it. So I did some bench testing at first. One to just kind of verify, one, is it strong enough to take a beating? And two, is it strong enough to actually lift something up and down? What were its capabilities? And so, well, that just turned sideways for no reason. But basically what I did is I stacked about 25 kilograms directly on top of that slew bearing and just let it continuously rotate for about an hour. And it never missed a beat. And actually I could have put more weight on it. I was just kind of getting bored by that point. So I think it could easily have handled another 10 kilograms, something like that, and just sat there and spun just as happy as could be. I didn't get any pictures of it, but I then mounted it to my workbench with a 100 millimeter arm that I also 3D printed and was lifting weights until I got to where it started failing. And it lifted, I forget the weights, but the torque came out to be about 7.8 Newton meters, which I think is around 6.5 foot-pounds, somewhere in that range. So pretty good for a 3D printed drive. But then what I did is I added a second arm and added a counterbalance, and I had 20 pounds on each side of that arm, and it was able to turn as long as it was a balance, it was able to turn. So I felt pretty good about that. So I took my little 1 meter grid antenna off of its pedestal. And I'll zoom in a little bit. These are a little small. So I took it off and I built a little test bed. And I used it's not in this picture, but I eventually added a 4-pound hammer. I call Old Betsy, that to the back side of it there to act as a counterweight. And I have just a PVC pipe that everything's mounted to, some wooden blocks for bushings, for bearings, and just mounted the 3D printed drive directly to the sawhorse. And I made this little coupling device to couple to the PVC tubing. And so then I took it through its paces, and we're going to see if these turn sideways too. But this was just an initial, just kind of a sweep test. And you can see it's moving this. These are full steps too. So it's slewing really fast for its size right now. That's 17 seconds to rotate almost 65 degrees, something like that. So it's really trucking. And then put it through a second set of tests where at first was just doing 1 degree, 2 degree bumps to see how it would. And it's not balanced perfectly, so it gets a little bit of wobble. And of course, it's on PVC pipe. So it's not, that's not the most stable either. But it did give me some really good results, something that I think I will continue to move forward with. So I can then print out 2 of these and have one as an azimuth and one as an alt drive. And with this control software, I've already got capability of adding at least 2 stepper control motors to it. So I can control both of those and then take some input back from the encoders, and then maybe I can start actually doing some tracking through the sky. Is kind of the ultimate goal of this. Simple goal right now is, instead of every 5 days me going out in the dark with some wrenches and a flashlight trying to change it 2.5 degrees to do my drift scans, I could just punch a couple of buttons and have it do it for me. So, but it's really promising. It's really simple. It's really cheap. Those motors are less than $20 a piece. So I'm really pleased at how well it's worked so far.
Wow.
And that's it for me.
Any questions for Nathan? That's good work.
Very good.
The links that you have there, if you can post those, because we can't they can't get the links from the video.
Yeah, I'll post the PowerPoint to the listserv
Okay.
and just say this is from our Drake's Lounge today. That way the links will be in there, videos will be in there. You'll be able to see everything as it goes on.
Great.
That's it for
Let's
me.
see. Helen.
But thank you. This is really informative. That AI scares me, but anyway, it spooks me. I'm having problems with my equipment. In fact, I borrowed a Zoom so I could log in today. I can get it on my iPhone, but the screen is so small I can hardly see anything. So I got to get my equipment over, and the nearest place that fixes it is a good hour away, and I don't drive. So here, eventually I'll get that taken care of so I can be up and running. In the meantime, somebody recommended a book on this broadcast of star noise. So I've been reading that, and that really helped because I'm light years behind all of you as far as information and knowledge goes. So, but I'm trying best I can. I guess that's it for now.
Okay. Thanks, Helen.
Well, thank you.
Steve Black. All right, he must have stepped away. Don Latham.
I'm here. I don't really have much to report. Still working on that front end possibility with the noise sources.
Okay. All right, thanks. Jack Lobinger.
Well, hello to everybody. I've been gone for a while, but what I've been working on is a couple of things. First thing was that I wanted to convert my existing 3-meter that I did the journal article on the closed tracking and system. I wanted to convert those from just DC motors with external encoders to a real servo system. So I've basically bought a pretty good servo controller for DC motors or DC servo motors from an outfit in Italy called Solo. And I've built a encoder closed circuit motor control system for both for the azimuth. A little different problem with the elevation. Trying to find a linear actuator that's got built-in encoders, but I think there's an outfit out of Canada called Precision Automation. I think that's what they're called. That I've used their non-encoded linear actuators, and they've now got one that's got an encoder built into it. So I'm going to employ that. The other thing that I've been working on is basically a scanning system. It's not quite like a raster scan, but it's a scan in fixed declination and scanning about 10 degrees of RA to either side of 5 degrees either side of an object to try to prove that I'm pointed in the right place. And it basically does that scan automatically and then plots the resultant power curve, and you can tell whether you're pointing at where you think you're pointing. And that's I've got that done. I just have to make that work, and that works in conjunction with the servo drive for the antenna. then the only other stuff I've been working on is that I've got a home machine shop, and I've been converting all the motor drives for my mill and lathe and stuff to servo systems. I've kind of gotten infatuated with servo systems, but anyway, I've been doing that, and then Rich, as I told you, I think at one point, I've had some medical issues with my family, so I'm been kind of taking care of those. But other than that's it. But it's keeping me busy.
All right. And how are you doing on the VLF work you were doing for a while?
I haven't. I haven't been doing any VLF stuff. I've been doing. I was doing a hydrogen line stuff and using the Wolfgang's program from that he was generous enough to let me use the community version of that program, and I've automated that so that I can take repetitive images and do a lot of stuff there. But I'm sure all Ted's stuff is way in advance of that. The thing that this thing does from Wolfgang is that it does produce FITS files, so all of the data is basically in FITS file form, which is pretty good as far as the depth of information you get out of each image. So.
Oh, okay. All right. Any questions for Jack?
Yeah, I have one question, and it's kind of general. Do we have a community FITS file header for Sarah or for the amateur community? Because you can have all kinds of stuff in the FITS file metadata.
Right.
Do we have a standard one? I'm thinking in terms of Ted Cline's efforts. And if there's not a standard FITS file that we have for our use, it's going to be really hard to be transferring files back and forth.
Yeah, not to my knowledge, we do not. I mean, somebody else here may know better than that, but I've never heard of one for our group. I am using the default header that Wolfgang's. I think actually the software that Wolfgang gave me, must have been developed with his academic connections to Bonn or whatever, but it has its standard of header and file structure, but I don't know of any standard that we have. No.
Well, does that seem as if it has the information that we would all like to have?
Well, I can. It certainly has all the information that I would like to have. I would be glad to publish a printout of that header, and with all its data for everybody to take a look at. And if everybody thinks that's a good idea, then we could use it. But that's I'd be glad to do that.
I think that'd be a step forward, because we've referred to it on and off, and some people seem to have trouble with the idea of the FITS files. But on the other hand, they are sort of what one might call an industry standard. And if we had our own, it's not necessary that it be, quote, our own, unquote, but simply common, so that we could swap data, and so that we don't have uncertainty when we use something like Ted's really good ezRA stuff for display and so on.
Right. I'll put copies of the one that I'm using on the forum, and everybody can take a look at them and see what they think.
Okay, great. Thank you.
Yep.
Thank you, Jack. I'm interested. Following Wolfgang's lead is not a bad idea.
Well, and they all are obviously modifiable and population-wise capable through Python, which is a great idea. So anyhow, yeah, I'll be glad to do that.
All right, great. Dennis, is it Hoofnagel?
Yes, perfect. Right on.
Excellent.
I'm a total newbie, and thank you for accepting my my dues for joining. And I'm W7YHR. Haven't been really active for many years, and I'm getting quite interested in what I've seen on YouTube. You guys demonstrating hydrogen scans of the Milky Way and so forth. I think it would be a really nice addition to have a video like that that goes into our astronomy club's gallery of still images. I think it would be a surprise to everyone to see some good radio astronomy. Yep, that would be a lot of fun. So I'm just barely getting starting to get things together for pretty much the scope in a box, parting it together. And anyway, about the only unknown I have is how it's possible to feed data to the Stellarium program. So anyway, I'll let you guys go on. Thank you for enjoy your meetings and your YouTubes, and I think you have a very interesting group going. Appreciate you being interested and all the technical expertise I see. Very, very exciting. Thank you.
Welcome, Dennis. Now, why would you want to feed data into Stellarium?
Well, I've seen videos that show over time the rotation showing on Stellarium a rotation of the Milky Way galaxy as it's.
So the current state of the sky presented by Stellarium.
Yeah, well, yes, overlaid on Stellarium, the data that's been received from the antenna and the reception of it through the SDR.
So, Alex, you've taken a picture of Stellarium and then plotted your data on it. And so I think that's probably what we're talking about here. Sounds neat. There are other programs that plot the sky and people put data on that as well. Alex?
Dennis, it overlays Stellarium, or it's two screens? It's Stellarium and a screen showing the spectrum of the hydrogen adjacent to each other.
Two screens, yes.
Yes. Yeah. Okay. That is a screen capture program.
Okay.
I'll find the link. It's one of the old links, and it shows you exactly how to do that.
I would appreciate that.
The other way of doing it, of course, is to use Radio Eyes, and you can put in the coordinates for the beam position into Radio Eyes, and it will show you the location of the object that you're supposedly pointing at from the positions that you put into Radio Eyes, and that's simply a serial connection into Radio Eyes.
Huh.
Didn't they also have was it Virgo that also showed something like that? It had a map of the galactic hydrogen, and it showed you as like a red dot where you were going across, and then like an output of the spectrum or something like that.
Because it was collecting data at the time. Virgo.
Yeah.
We're interested in all good ideas. Thank you, Dennis.
Thank you.
All right. Dennis, quick question since you're new. Where are you located and what kind of equipment do you currently got?
I'm up in northwest Washington State, about 90 miles north of Seattle, about 30 miles south of the Canadian border, in a community called Bellingham. And and today, believe it or not, we have totally clear skies. Beautiful day out. 70 degrees out.
Oh,
Spring
wow.
is here.
Ooh.
And as far as equipment, I'm just I've been busy with my career, and I'm sure many of you have found the time to do a lot of this only after you officially retired from your income producing pursuits. And so anyway, that's been the case with me. I've been totally preoccupied for last 50 years, and now I'm going to focus a little more on some of the really fun things that I like to experiment with.
All right. And the beauty about radio astronomy is you don't mind the clouds.
That's right.
So I think you're in the right spot for radio astronomy.
Yeah, and the equipment's a little lighter than visual astronomy. I have a telescope now that I'm not able to lift the tube up onto the tripod.
Oh yeah.
So anyway, I guess I have to get me an astronomy caddy. The guy that stands alongside helps me out. Hands me the right eyepiece.
You can get one of those little ones that Robert has.
That's right. I've seen the guys doing that, and in fact, we have a couple of them in our club, and they're very dramatic. I was thinking though, for the Eclipse, remember you're only going to have 4 minutes of integration time, and I don't think that piece of equipment can integrate anything in 4 minutes that's going to be of any real legitimate value. And the other thing is, there must be some way to zoom out rather than in, and go out so you can get the disc in a wider frame and be able to see all of that corona. And maybe that's something that it's probably just a software thing, and probably ZWO could maybe jump on that really quick, maybe in a few days. Who knows?
Okay. Well, thanks, Dennis. Are you on listserv yet, or forum?
No, I'm not.
I don't know, Ted, if you can put that list, I recommend you get on that, because that's our sort of our 24/7, not help desk, but everyone talks on that. And you can ask questions, get involved, and see a lot of stuff real time.
Great. Thank you.
All right.
Appreciate your help.
Kevin Kell.
Good afternoon. Not a lot new happening so far. We're still waiting for winter to go away and spring to come out so we can get back outside again and do various things. So nothing for me.
All right. Kevin, where are you located?
Southeastern Ontario, midway between the cities of Toronto, Ottawa, and Montreal.
Oh, okay. All right. Thanks, Kevin. Bob Alexa?
Yes, Alexa's correct.
Does your phone try and your TV try to do things every time someone says your last name?
I don't have one.
Oh.
Yeah, I don't have an Alexis.
Mine would start talking at me if I said Alexa too much. All right.
Yeah.
Go ahead.
Nothing real exciting. I did join the forum, so I've been reading the different posts. I've been watching some of the videos about the ezRA tutorials and things, and I've also been starting to watch some of the YouTube series about the radio astronomy formulas. So that's kind of what I've been doing, just slowly acclimating to the terminology and what's going on.
Great, great. All right. What kind of equipment do you got, or do you have any?
I don't have any radio astronomy equipment. I have optical, telescopes and things like that. And one of these days I feel like I'm going to either go with the Super SID or get the scope in the box for the the H line.
Okay. All right. Well, glad to have you. Let's see.
Thank you.
John. Okay, Jon.
Yeah, it's me, John Richards.
Hey, all right,
Hi.
John.
So anyway, I'm in the middle of, I talked last time in our last meeting, I'm in the middle of refurbishing a 3-meter dish. So nothing really new to report on that. I did order one of those Discovery dishes that somebody mentioned in the last meeting. So I got, they're a 70 centimeter dish, and you can get different feed options. I got one to look at the L-band weather satellites, but I won't get it till it won't ship till June 30th, they say. So that'll be something fun to play around with.
All right. Okay, thanks. Ed Harfman, and if anybody doesn't recognize Ed, the introduction to radio astronomy YouTube video is Ed's. He did that. So go ahead, Ed.
Basically these days, I'm just counting down days, first to the eclipse and then to my long-awaited retirement. So then I'm hoping to have some time and start putting a bunch of stuff together. Some for fun and some for enjoyment, as well as, all the other fun stuff I need to do. But yeah, right now, just trying to keep my back underneath enough control that I can make it that far.
Oh, yeah.
So that's all I'm up to these days, unfortunately. Hoping to change that really darn soon.
All right. And for all you almost retired people, you're busier when you're retired. You're just not getting paid for it. All right. So if you just think you're going to have more free time, you're just doing it for free now.
I have no such delusions. I'm just hoping that the things that I'm doing are a lot more fun.
Yeah, that's true.
The garbage that I'm doing now.
All right. Thanks, everybody. Is it Sumio? Am I pronouncing that right?
Hello. I live in Kyoto, Japan, and so early morning in here. And I have been ham radio a long time. And I'm doing the meteor radio observation long days. So recently I heard the pulsar observation. So I just joined in ezRA, and I would like to much more get information for the radio observation, radio astronomy and radio observation. Thank you.
Oh, thank you. And are you on the listserv yet? Because this would be good for you since your time zone is so different.
Yes, now in about 4 o'clock in the morning.
Yeah, yeah.
And so I get up early, so not yesterday evening, and too late. So thank you for joining today.
Oh, thank you. Thank you. Hope you're enjoying it.
Hey, Rich.
Go ahead.
What's the time on the Australian?
The same, almost same, I think.
Okay. You if you haven't been joining that one, you should be.
Yeah, there's a Drake's Lounge Australia. That's America Friday night, Australia Saturday morning.
Saturday, 9 a.m. Melbourne time. All right.
You know what the UTC time is on that?
It's I think at 2300.
Yeah, it's about 23.
But
the
it
night
changes.
before. Yeah.
It's their 9 a.m. whenever that is.
Right. Yeah, that'd be great for Japan. That'd be a good one to, and feel free to invite any of your friends there, Sumio. It'd be good to get we can even get a Drake's Lounge Japan if we get enough people. Okay, Charles.
Let's see. Oh, haven't been doing too much. Got back problems giving me grief. Let's see, is my video working?
Yes. Oh,
I'm not seeing.
I can see your face if you're trying to share something. I don't see it.
No, I was just
okay. Yeah, we can see you.
Making sure you were getting me. Okay. Now having back problems. Was doing too much chainsaw work, getting ready for spring here. So I'm down to 1/4 speed now with my back sciatic nerve problems. So that's going to slow down my messing with the dish and doing stuff here. I had planned on working on the azimuth drive that's giving me problems, but I'd have to destack the dish to do that. And I don't think I'm going to risk anything while it's still working for drift scan. So done a little bit of VLF. Unfortunately, I had it off yesterday. It looks like I missed 4 flares in a row. I think there was a bunch of stuff showing up yesterday that I didn't catch. Anyway, just staying busy trying to do all the little projects that I can still do with my more limited motion. So that's about it here.
All right. Thanks. And for everybody knows, Charles is the one who does the historian work and the articles. So if you guys got any good Sarah history or radio astronomy history, that throw them an idea and maybe we can get pump out an article or some pictures and stuff.
Yeah.
Okay. I got Winslow Farrell on the iPhone.
Yeah, I don't know if you guys can hear me. I am outside.
Hear
just
you fine.
A sound check there. Great. So I had good intentions of joining Sarah more often, but I think that was about 1.5 years, almost 2 years ago now. So this is my first time back, but still working. But I want to show you if I can. I don't know if this is going to work. Let's see. Trying to, I guess it's, no, I guess not. So I wanted to show you that I do have a 3-meter dish in the backyard now. And maybe next time I'll figure out how to show a picture of that. So want to get a signal to it this spring, and I'm looking forward to it. Eager to, it's a stationary position. Didn't have the money to get a way to slew it yet, but that's maybe in the future. But then first signal, I hope, first light, I hope to be this spring. So thanks so much, and patience with me as I get to know what's going on here. Appreciate it.
What are you using for the receiver and software?
The software, primarily GNU Radio, I believe, and the basically the AirSpy and the SDR, the small SDR. I've got some other SDRs that I plan to use in the future, but that's effectively it. There's a helical antenna that I've put into the center of it that what I purchased from the Netherlands. They had a little can that I have in there, so it basically should be set up, ready to go in a matter of a few days if all goes well.
All right, and you're doing hydrogen line, and your
correct.
feed is
Yeah.
Your feed is a standard can. Feed.
That's correct. Yep.
Okay. All right. Okay, and I do recommend if you've got an RTL SDR, that you look at that ezRA program. because collecting it is one thing, and getting showing you can actually see it, but actually accumulating the data into being able to see where the galaxy is and plot
Right.
it is very, very fun, and it adds another layer to the enjoyment of this.
Looking forward to it. Yep, that sounds great. Thanks so much.
Okay, Joseph Sandy.
How's it going? I don't
Hi.
have a ton to share. The snow took my antenna down. It was pointed roughly 90 degrees, and then I came out the next morning and it was flopped all the way totally over towards the ground from the weight. So I just have it turned off for now because I need to wait for stuff to melt and dry up so I can get out there to reset it. I'm pretty excited for the eclipse. I found out that one of my family members lives in Indiana in the path of totality. So I ran out and bought plane tickets so I can actually go get a chance of seeing that. And it's funny that the seestar S50 was mentioned earlier because one of the other volunteers at LTO wants to send me with his to try and use it to capture the total solar eclipse. So I'm working with him on that, and I may even have one as well. I also have a telephoto lens here for my camera. So I'm going to try really hard not to compromise seeing the eclipse myself by trying to capture it. But I do want to set a couple things up and just let them go, without really touching it and see what happens. So, but yeah, I have a decent amount of elevation scan. Now, look, I was working with Ted the other day and we can start to see some of the arms forming in the ezRA software. So when I have even more, I'll share that. But yeah, it's a really cool piece of software. I like it so far. So, and the only other thing, this is going back to the visual side of things. I'm going to do one quick screen share. And if I can find the button here. Can we see this little guy here, this little telescope?
Yep.
This is my first visual astronomy telescope. I have two now. But the reason I like this is because it's 6 inches. It produces really nice views. I've had a lot of people that like it. It is very light and easy to move. So one of my big suggestions with it is if there's people who want to do visual astronomy and they can't pick up the big heavy telescopes anymore, something like this is really great. So that's about it. That's all I've got.
And a plug is Super SID. I was able to pick up the Eclipse with Super SID.
And what exactly is Super SID?
Super SID is a VLF 20 kilohertz, and it's used for solar flare detection. It's just a little can it's a little snuff can about that big, and you plug it into your computer for power, and you plug it into a big wire, a couple 100 feet of wire in a square formation, and you can pick up the VLF signals being transmitted from the different VLF stations used for submarines.
Oh, this is cool.
Bounces off the ionosphere, and when a solar flare hits the ionosphere, it changes the ionosphere reflection, and you can pick up a blip where the flare happens on your Super SID. And it's all software's already done. There's big databases with it. But what I did was I had the VLF station on the opposite side of the Eclipse than when my station was. And when the Eclipse passed, I was able to see a blip almost like a solar flare, because it's it looked like a sunset sunrise thing to the Super SID. So you can pick up the Eclipse with the Super SID.
That's pretty fun. Where do you get them at?
Just go to the go to our website in the store and order it.
Okay, yeah, I think I actually see it right here, I think.
Yeah. So anyway, so if anybody has a Super SID, then just think about setting it up for the eclipse. And depending on your geometry, you might be able to see it or not. But I was able to see it just because I was in the perfect location for the 2017 eclipse. Okay.
Cool. Yeah.
All right. Let's see. Well, thanks. Let's see what do we got here. Jeff Flatten. I'm pronouncing it right.
Yep, that's pretty close. Close enough. I mean, that's how I do it too. So hopefully you guys can hear me.
Yep.
Yeah, like some of the other people on here, I've been meaning to join Sarah for years. I've been reading the books, going through your website, learning everything I can. And it's just finally with the eclipse coming and you guys having the conference down there, I thought, now's the time to do it. So I just jumped right in and it's like, here I am. So this will hopefully get me going a little bit more. Cause like I said, I've been meaning to do this for years. So.
Yeah, I think we're at the stage where it's, especially the hydrogen line, it's so easy to do the hydrogen line and get super quality data. And to see the galaxy and everything like that, I think that this so much more advanced than even 3 or 4 years ago. So I think it's good to jump in now. Okay, Alice.
Yeah, hold on here. Let's see. Okay. Hold on. Let me. Something's wrong with my camera. Let me go get the little thing on.
Okay, Alice, I can't hear you.
Can you hear me now?
Okay, there. No
Okay,
video,
yeah.
but I can hear you.
Yeah, I've got the camera is probably okay. I'll just turn off the video. Yeah, nothing much going on here. I enrolled in a space weather certificate from Millersville University. So that just started. And it's been very interesting so far. I mean, they were talking about the first course has to do with just natural an emergency primer for natural hazards, and they were mentioning about they go through all the natural hazards, but not just space weather on this one, but they also talked about the issues that faced the Apollo astronauts when they were going up, and the big solar storm of August 1972, which came right between Apollo 16 and Apollo 17. And if they'd been on the moon at that time, they probably would have had very serious acute radiation sickness or possibly killed them. They were really lucky during that whole program. So that was pretty interesting. We heard a talk from somebody from NOAA on that. But that's all I've been doing really. Mostly just focusing on the sun. In this particular program, it's space weather. It's just the sun stuff. But otherwise, I'm just kind of lurking. It's fun. Over.
Over. Okay. Hey, thanks, Alice. Andrew Thornett.
I keep forgetting to unmute myself. Hey, hi guys, how's everybody? A bit late in, I apologize. I got my time mucked up. Sorry about that, Ted. Ted and I were supposed to meet beforehand and I got my times completely missed. I've been watching his picture change while the meeting's been going on. He's gained a hat now. Anyway, so update from here in Lichfield in the UK. Well, I've been having some fantastic help from Mike and Jan regarding my interferometer, although I still haven't managed to get it working, and things have had to go on hold for a week or two because my mum's become seriously ill, sadly. But I don't know what's going on there. I think I'm back to really what typifies me as an individual, which is all this success that I've had since September, and everyone keeps congratulating me on all the things that I've managed to do. Well, that's the thing that's abnormal. The normal Andrew Thornett is a completely incompetent imbecile who can't get anything to work. So at the moment, the interferometer, which should be working even on the sun, doesn't seem to work. But there we are. Anyway, apart from that, I have managed to do is make a cantenna, which is really quite, for anybody who's not done it, I can really recommend that. That's really incredible how well that works. Here in the UK, trying to get one of the larger tins was the difficulty, because we tend to have things in somewhat smaller containers than it sounds like you guys get. But eventually managed to source some on that wonderful source of all things strange, eBay, some old large coffee tins. And one of those, a little N-type connector, and a super new type of metal for using for my waveguide inside, i.e. a paper clip, which I straightened out and cut to 49 millimeters and soldered onto the end of it on the inside, worked perfectly. And I'm in the process now of mapping out the Milky Way using a can, which I think is absolutely hilarious. I would say the interference on it is a lot worse than it is on my array, which I'm also continuing my mapping exercise on. But nevertheless, for anybody who wants to do it cheaply, just get a can and stick something on the inside of it, and you'll be amazed at what it can achieve. And if I can do it, anybody else can do it. One recommendation is get some cling film, that plastic film you use in your kitchen, stick it over the end of the tin so it doesn't fill up with water when you're actually doing your exercise. Apart from that, I recommend it. The other thing that I'm doing, which has been my major thing of the last few months, is I know variously people say, is this radio astronomy or isn't, but it's actually muon detection. Here in the UK at the British Astronomical Association Radio Astronomy Group, we do consider it to be part of radio astronomy, and the UK Radio Astronomy Association sell detectors based on the Cosmic Watch program, which some of you might have heard of. And I recently gave a talk at European Astrofest in London on this, which went down very successfully. And we even had a crowd of people downstairs next to the British Astronomical Association stand blocking the corridor, which was amazing. I don't think anybody's ever seen a radio astronomy project on a stand actually block the corridor with interested parties, but it happened. But I don't know if there's anybody here who's ever made one of these, because my next bit, I'm trying to actually demonstrate these muons. And so I'm trying to build a cloud chamber. And I've been doing that the last few days. In typical Andrew fashion, I can't even get the cloud chamber to work. So if anybody here has ever made a cloud chamber and can contact me, it'd be really greatly appreciated. That's it.
All right. You got any pictures or of your cantenna or anything, or is it? Oh, it's on the antenna.
I can find you some. Excuse me. Bear with me. Pictures of cantennas. Sorry, but just a second. Building cantennas. Right. Share screen. There she blows. It's absolutely compulsory to have a vegetable in the background with a face on it. That's really what makes it work. So you can see it's just a large. This is 15 centimeters across, this or diameter tin. Apparently the length doesn't matter. So I've read, not that I would understand. And I'm not even entirely sure. I'm pretty correct on this. I'm not even sure how much it actually matters how wide the diameter is. But apparently the distance from the bottom, which on this particular case is on the left-hand side of your connector, is rather important. So that has to be measured out and calculated correctly. And the size of the waveguide inside matters. So let's see if I can find you a waveguide picture. Wait a minute. Why is this not? Oh, hang on. Here we are. So you can see there the waveguide on the inside, which is just a paperclip. You know, again, I was reading some websites about it, and people were saying, "Oh, it's supposed to be a certain thickness, this wire, and probably matters what sort of wire it is. But blow that for a lark. I just want to try and find some wire. So straight and paper clip is what I went with. I don't think the type of connector matters at all. It's just a nice big N-type one. It gives them some strength to it. What else we got? And there you are, just showing it close up, where I've don't know why I even put that picture in, but there we are.
Excellent. Okay. Thank you, Andrew. Yeah, the diameter of the can has to do with the filtering capability of a cantenna. It's really a waveguide, and it's nice that it throws away a bunch of nasty signals that we might have. And if the can is even longer, then it hopefully filters even better. So many experiments.
Yeah, but it's just, I mean, absolutely incredible how easy it is to make. And a number of people had told me beforehand when I was doing all the array. I mean, for those who remember me, I've got this very strange aerial I do my hydrogen astronomy on, which is an old military array, which works very well. It's just as rare as hen's teeth. No one else is ever going to find one, it's just like, it's not a very good example to show other people who are trying to get into the hobby. But something like a can that you stick a little bit of something on the inside of, and only takes you, I mean, it takes less than an hour of an idiot like me putting it together. I'm sure anybody else could do it in 10 minutes. And if I can make it work without any problems, believe me, anybody else can.
The what's the distance you put it from the base of the your dish? And is that did you calculate F over D on that, or
say it again?
The distance you put the cantenna from the base of the dish.
It's got nothing to do with any dish. What dish?
Oh, you did it. Oh, this is pointed straight up.
Yeah.
Oh, wow.
This can points straight towards the sky.
Okay.
Forget that. I may even have a picture showing. Hang on, I think I've probably got somewhere a picture showing it actually on its outside. No, that's the whole point. It's I'm trying to find something which, here we are. This is now don't get carried away. This shows a dish, but the dish is irrelevant. The dish was just being used as something to mount it on. So that can you see it? It's not actually pointing towards the dish. It's actually pointing up towards the sky. They say the dish just happened to be there as a way of actually giving a pointing direction. Do I have another picture to show?
Have you got any
here we
dots yet from?
Sorry, here's a better one. A second. Showing it. Oh. I got everybody's picture in the way.
I was at first confused by that little black box, but that's the old feed for the original dish that just happens to be there. Otherwise, he's just taped it onto a stick.
You got it. Wait a minute. Here we are. I got a better picture to. So I got too many things open at once. Where are we? Here we are. Coming up. Can you see that?
Wow. Yeah.
So the whole point is to produce something really simple, which anybody can use. So I'm trying to produce a project which is sellable to the general public at large, or at least the general astronomical astronomical community at large. I'm interested in getting people who know nothing at all about radio astronomy, or radio for that matter, to get interested in this part of the hobby, because that's where I come from. And I try to encourage them, particularly because my biggest concern is that, particularly here in the UK, light pollution is of pandemic proportions. And people have been really put off astronomy as a hobby. And I'm trying to say, look, there's something really exciting here that you can do. But people have already spent thousands and thousands on their astrophotography setups. And I will not detract them in if I do anything that's expensive. And here we've got a can that costs, with all its bits and pieces, less than £10. We've got an SDR, software-defined radio, that costs you about 30 quid, and you've got a one of these Sawbird H1N LNAs, getting about 30 or 40 pounds. So for less than 100 pounds, you can build yourself a hydrogen line telescope that can map the Milky Way and demonstrate dark matter. And I think that is absolutely amazing.
So now Sarah's going to have competition with the BAA with a can in the box. So I think this is great. Let the battle begin.
But you get tomatoes with theirs, so that's nice.
That's right.
There is a serious reason for this. Have you seen the price of the Newlac aerials now?
Yeah.
The first one I bought cost less than £50. Then the price went up to £99. Here in the UK, they're trying to sell them for £132 per aerial. I think basically because SARA members bought a number of them when they thought we were into something here, started selling the things. But it's appalling. You know, they really aren't worth that money, I would argue. It's just, I know it's nice to have something that is actually tuned to 1.4 gigahertz, but still ripping people off seems a bit unfair.
Do you do you have any plots from an ezRA with the data you got from that can?
Not yet, because I haven't got enough data points.
What do you think? What do you think the beam width of that is?
Oh, I don't know. I don't know those things. You're mixing me up with somebody who understands anything.
Now, Andy, you got put in the chat a link to your latest post to show you that, yeah, we can get a in power grid, a power plot across the sky. So he's made some progress, at least with one trace.
Yeah, I mean, something very important I do want to show people. I mean, I know I put something on the mailing list about this, but if people don't mind, I'd just like to show another picture. Where are we?
And while you're doing that, anybody know he's got the ridges in the can in there, as opposed to is that doing anything to the signal? I mean, is it better to have a clean can or something with ridges in there?
No, it doesn't matter either way.
Okay.
You could have more fun if you soldered another can on the front end with both ends cut out.
Oh, would that make it more effective?
It would make the beam width a little bit tighter.
All right. Okay.
The other thing is that what you use, paper clip, is fine. The size of that stub, if it's fatter, it's a little bit more tolerant in terms of its length or its Q, but it really doesn't matter that much. The distance to the back is crucial. Quarter wavelength of the waveguide.
So well, that's what I'd read. That's what I'd read.
That is that's fairly important. The rest of it is fine, and I think the designation, if I remember correctly, that's a number 10 tin can.
Does the width of the tin can make much of a difference?
The size of it, the diameter does, definitely.
Okay.
The length, as long as you get at least a quarter wave, which you apparently have toward the mouth, is good. But another one soldered on would be more interesting a little bit, but not necessary, as you point out.
Well, I've got some spare. They came in a box of 6.
Cans?
Cans.
Oh, well, solder another one on the front of it. Solder 2 more on the front of it.
Although that's more work, of course. That takes up the produce yourself a hydrogen line telescope from 10 minutes to, I don't know, 20 minutes.
Yeah, right.
But you might cut yourself as well, you know. So if you're doing, I mean, on a serious note, if you're doing a group activity, then things like whether the astronomy group is going to end up with a load of people with great big holes in their arms becomes quite important. Right. So by keeping the can as it is, we limit the risk of injury.
If you have a group enterprise, you can also use pop rivets to hold the connector on.
Yeah. Oh, but a bit of glue worked as well. But I think that's what I used.
Oh, it's glued on?
Oh,
my.
did I put a screw in? I think I put a little bit of solder, and then I just glued it.
Yeah, you got to have at least one screw or some solder to make sure it's connected. The ground is connected properly.
Yeah, I think I soldered it then and glued it with Gorilla Glue, I think.
Ah.
Yeah. So what do I want to show you? I want to show you this. This is a ULEC mesh aerial. Just in case anybody's wondering where those holes are, should be connected. It did fall over, but it didn't really face that much strain on it, and it just snapped. I'm not very impressed.
Wow.
So it was blown over by the wind, but I mean, it was only like half a meter, 60, 70 centimeters up, and it really didn't have that much of a bang. So
that looks cast instead of pressed.
Yeah, that's a cast aluminum dish. It will not. It's very fragile. It's brittle.
Yep.
Brittle
You're
aluminum.
right. You're absolutely right, Alex. It is. The pressed ones are a heck of a lot more robust and cheaper too, I think. Wow.
So if any of you are thinking of buying a new ULEC dish, then that might be relevant to you. What else have I got? Oh, this I wanted to show you as well. If you're thinking of how you're actually going to change the elevation of things like these antennas, or even quite a small dish, these things are available from camping stores. So they're, as you can see, it's a bracket. So it's not camping stores, sorry, from aerial stores. For putting on your roof, and it's a bracket with like a variable thing on it with a 1-inch tube that you can slot into it. So I found that 2 of those sort of screwed together allows you to vary your angle wherever you want across the sky. Just a thought.
Nice.
Yeah.
Okay. Wow. Good stuff.
And one last thing, and then I'll let somebody else talk. This here, so this is my latest hydrogen map. Oops, it's gone. Was my latest hydrogen map. Go back again. There. So this shows the Perseus arm in its glory, and faintly the next arm out, which is what, again, I just find absolutely incredible with the couple of things about this hydrogen mapping exercise. We're not just taking a picture of the Milky Way and showing its arms. We're showing them, first, it's like a CT scan, as if we're outside looking down from above, which is quite incredible. We change our point of view. And secondly, we get distance information, so we can see stuff that's behind stuff and show it on there, which is well, just all this stuff is incredible to me. Still blows my mind that we can do that. So anybody here who's thinking of doing hydrogen line observing, this is the type of map that you would expect to be able to get out at the end. And I'm doing it with minimal equipment, and I will be coming back in a few weeks and show you what one can on a stick can do. This is with an 86 centimeter military array, but it's previous tests have suggested this is performing at about the same level as a 1 meter class dish. I can tell you what a 15 centimeter can does in a month or two. And that's me done.
Wow, great job. Any other questions for Andrew? All right, thanks. Steve.
Hello. You can hear me?
We can. I can see you too. Yep.
Okay, good. I'm outside by a busy street, so I hope that everybody can hear what I'm saying. But yeah, I like to dabble and tinker, and I was actually interested in. I was reading about our worldwide attempts to find Earth-crossing asteroids, and most everything they use to find Earth-crossing asteroids or objects is visual observation during the night. And I had been reading a little bit about radio astronomy, and also I found out about an ability to track airplanes with passive detection. That is, a strong radio station, such as a TV station, the main signal directly from the station is correlated with other signals from other directions. And however they mix is a function of an object in the air. And so there are actually devices that are used in the world where people detect airplanes without being detectable themselves. They can spot stuff just like radar, but nobody can figure out where they're operating from. I thought, I wonder if that could be applied to near Earth or Earth crossing asteroid detection. And so I started dabbling with radio astronomy, and it's very interesting. You know, I've got this little G3 JVL design behind me that I think I'm 90% sure it can see the sun. That's about it. Gain's kind of low. I originally set out to make 4 of them and point them all in the same direction, and then put all the signals together in a combiner. But yeah, the hydrogen line detection is a very interesting little adventure. But I was, telling you why I was interested in getting into radio astronomy, and it's a long shot. I know there's, path losses are unimaginable, but just like the stuff a lot of y'all are doing now was thought impossible, say 20 years ago. Maybe 20 years from now, if we all are messing around with different ideas, we'll be able to find Earth crossing asteroids in time, to at least hunker down. And maybe even find some during the daytime too. But at any rate, that's about it. I've just got involved in this one because I saw that they started having it, I guess, from 1 to 4, and every Sunday from 1 to 2, I'm occupied. But thanks very much. Back to you.
Well, a couple of questions. You got your antenna sitting out there. What's the frequency, the type, and why do you think that's what reference you used to say that was the right frequency for Earth crossing asteroids or meteorites?
Okay. The underlying motivation for a radio astronomy adventure was an interest in seeing how reachable or feasible an Earth crossing asteroid detection would be. But this does not, I didn't imagine that this would ever detect Earth crossing asteroids. These two remotely related ideas are only connected, by just an imagination. So this is a G3 JVL design that's 22 elements. It's just for hydrogen detection. I built it to detect 1420 megahertz, and I've used with new radio. I think I'm sort of able to see the sun. I was able to find it a couple of evenings. I was able to find it in the afternoon right through an exterior wall in my room. But I think that to be able to make any decent observations with this, it would need to be combined with three others. That was my original intent, is to put about three of them together, and then I'll have something that's maybe the equivalent of a meter dish in gain. But also, I've been experimenting a little bit with the Virgo Astro software. I haven't seen a lot of recent comments about Virgo Astro. I don't know, is it because it's all, I guess, command line interface stuff, and maybe with other people's success and being able to attach the plug-in, the SDR Sharp plug-in for IF averaging, maybe Virgo Astro just got swept under the carpet or something. I don't know. Back to you.
I think, if I'm not mistaken, I think development on Virgo kind of came to an end, kind of came to a stop a few years ago. It's I think the last time I tried to run it, it still required Python 2. It wouldn't even run on Python 3. So I don't know if it's actually even been updated in the last 5 years.
Yeah, I've been using Python 3. It's fine, except that I did compile it off of GitHub. Okay. And I think I tried a repository package and ran into some problems with it. But I think I compiled it myself, and it works fine with Python 3 in my experience so far.
I'll have to give it another shot, because I remember I tried to run something. I don't know if it was Virgo. I may be getting it confused.
Okay. And Alex, how is this comparable to the patch antenna you've been doing, the one he's got in the background there?
I don't think it is. I think the problem with that loop antenna, although the rings may have similar directionality, the feed is a big deal. I was very impressed with the side lobe rejection of the patch antenna, of the patch feed, and I think that's the key to that. That one that Steve has, I think it has a very wide exposure to ground noise, and I think that's probably the problem, is that the feed point being one of those loops exposed. If you could put a can around it, it might work. Go look at some of the videos that I put around. Honestly, if you could do a loop feed in a can, it may provide better directionality and help eliminate some of the ground noise, and you may have better detection capability with it.
Thank you. All right.
Okay. Steve, great stuff. Keep going. And I'm very intrigued about your asteroid detection thoughts here. That'd be fun if we can get that working.
All right. Appreciate it.
Okay. And Jamison, I think you're last but not least.
Hey, how's it going? Let's see what I've been up to. I got my technician's ticket. Yay!
Yay!
So I got my amateur radio license. That was the big news. I've also been gathering some data using the CPY, the circular patch Yagi antenna. It's the smaller version. So I sent that data to Alex today. That's the first 24-hour run. I think I'm getting some signal attenuation. I've been using a length of cable from our old cable company that was going from outside into the basement, and I strongly suspect that's attenuating the signal, but I don't know. I'm gonna be I'm thinking about putting a new hole in the wall of the house to run some cables and see if that improves things. I did take the antenna to a science fair, and the kids loved it. It was really cool looking, if nothing else. They thought it was just wild.
The cable company cable's probably 75 ohm.
I think that might
and not 50 ohm.
Yeah, I think that might be a problem. I still feel like a noob when it comes to radio stuff and antenna stuff. Part of the reason I got my amateur license is I was told by some radio friends, hey, if you want to learn about antennas and attenuation and all that stuff, hang out with hams. You will learn a lot. So I've been sipping from the fire hose.
That's true.
A buddy of mine, when he saw that I got my license, he's like, hey, come on over. And he showed me like his man cave and like all the radio equipment he had and cables and what he's done. And my head was very full when I left. So the other thing I'm working on, and this has been sort of slow progress, but I'm trying to build the IF average plugin so that it can be updated to work with newer versions of SDR Sharp. I'm an Android developer, so I ran into some problems right off the bat. I knew I was in dependency hell and things were not working out. So I brought in a buddy of mine who's very knowledgeable in Windows and C Sharp, and we kind of came to the conclusion that it might be best to start with a new plugin from scratch and pull in the old code as we could. But we were just running into dependency issues that just looked kind of intractable. I guess IF average is a couple of years old and SDR Sharp has moved on. So keep your fingers crossed. We're hoping to make some progress on that and come up with the IF average 2.0 with a little luck. And I think that's pretty much it.
Thanks,
I wanted to say about the cloud chamber too. I have tried to build one of those. They are hard to build. I built something. It was a little plastic container filled with, you have to use very pure isopropyl alcohol and set it on a piece of dry ice. And I could not get it to work. But at the science fair that was at one of my kids' schools a few years back, someone built one that worked great, and they used a CPU cooling mechanism. Like people are really hardcore and get these liquid cooled, CPU coolers. That worked great. It worked. It was really just spectacular. You could see like little particles zipping through and so on. I had the instructions. I think they're lost at this point because it's like the kind of thing that is like, oh, that might be fun to build. I just never followed up on that. But I would be willing to talk with you further. I think this was Andrew, and tell you about my experiences. And I'd be very interested in seeing like how things work out for you. And I'll see what I can dig up from. I may still have the file lying around that explains exactly how to build one.
The Peltier coolers for that need to be at least a double stack. You need at least 2-stage cooling for that, maybe even triple to get down to the point where you have that condensation temperatures of equivalent of dry ice.
It is very tricky, and apparently it's very twitchy. I just could not get the thing cool enough so you could get that hyper saturated environment where there's alcohol that, when something goes zipping through, it basically makes a contrail behind whatever the particle is, and that's what you see. But I will see what I can dig up, and again, I'm happy to hear what you're doing and share what little I know about it.
Okay, great. Well, thanks, Jamison. Okay, anybody? Did I miss anybody? Now the chat is, if anyone wants to save the chat, you go down to the bottom right on the chat, or the 3 dots. There's a save chat function, and I think it saves it to your. The question is, where does it save it on your computer? Is the real question. So make sure you understand where it's saved after you save it. We will also copy that chat and put it in the YouTube video under the description, so you'll see that. Last but not least, and for your new hams, and congratulations on your technician license. The nice thing about radio astronomy is you don't need one. You don't need a ham license, but that's okay. I mean, most of us are hams, and that's how we got started in this stuff. Last year we did the ARRL antenna book. We added the first ever radio astronomy section. I'm working with the ARRL engineering book as we speak to put in the same approach for the engineering book, but instead of just the antennas, they're going to add in the receivers and software and the systems in the engineering book. I am looking for more input. If anybody has an article that they wrote for like one of the journals, and you can tell me where that journal article is, or even send me that, then I can send that to the editor, and he'll maybe incorporate that into the engineering book. And what we're looking for is complete systems, like for the meteor detection or super SID, or radio Jove, or the hydrogen stuff. Is what is the complete system, and particularly is once it gets out of the antenna into the receivers, LNAs and stuff, and how do you process it to produce hydrogen pictures, things like that. That's what they're looking for, the complete system, and more emphasis on the back end than the antenna. Okay, so that's going on. So I'm looking for that input. If anybody's got it, just send it to me. Also, I am looking for articles for the March-April journal. You need to have your article or your observation report by April 12th. And all of the stuff you guys just showed us, you can put in a 1 or 2 page, here's what I did for my system, or my antenna, my azimuth, or my elevation system. That is perfect we can put in the observation reports for your just a small write-up on what you did and some pictures. Okay, so think about that. Thank you very much for everybody. This was really fun, and we'll be signing off. Thank you.
Wait. Russ, I have a comment to make.
Go ahead.
Okay, earlier people were asking about the nice pictures that people take of the corona during total eclipses. And what people need to keep in mind is that those pictures are done with Photoshop after the event. And they take like 5 different pictures. They take a fast image, close to the sun, because the corona is really bright there. They take another picture just a little bit longer, and another picture a little bit longer, and they keep going out to get those, and then they take and they combine them, with layers in Photoshop to get those nice pictures. But anyway, I've been so focused on getting ready for the conference and everything. So what I'd like to do is I'll share my screen one more time and let you know that that I have other things going on. Here it comes. Can you see it?
I see a crescent.
Well, what you see is a partial solar eclipse, and the one on the left is zoomed out, and the one on the right, is actually the other way around. One zoomed in, the one on the left is zoomed in, the one on the right is zoomed out. And this is the second system, that I have, that I'm taking to Dallas. Now, I hadn't considered streaming this, okay, but these are pictures taken with the Nikon P1000, okay, and it does a reasonably good job. So anyway, I just wanted to say that we have what everybody's asking about with the size of the image and everything, and zooming in and zooming out. It's covered, but not to the same extent that what they do. Taking all the images and putting them together with Photoshop and showing it afterwards and say, oh, this is a nice picture. I don't think you can get that kind of picture with this seestar. And the seestar, I agree that the field of view is very tight and you won't be able to see an awful lot. But I suspect that even though, okay, it's almost a 4-minute eclipse, that there's a chance that, we can see a nice corona around it. Okay, so that's it. Does that help to explain anything?
All right. Okay, thank you very much. I can't wait to see all this.
Me neither.
All right. Well, have a good week. Let's see. This next Friday, let's see. That's U.S. time. But it's Saturday morning Melbourne time is the Drake's Lounge Australia. So for our Japanese contingent there, that'd be a good one to jump onto. So it's 9 o'clock Melbourne time, and we'll see you guys then. Okay, night.